What's up? Welcome to Backend Stuff. I'm Jacob Blitzo, here to help you build tech for the future. Think about scalability, reliability, and cost. If you want to learn how to build scalable, production-ready APIs, hit that subscribe button now. This is episode 12 in Elixir Basics. Today we are diving into binaries. What is a binary? A binary is a data type in Elixir denoted with the double chevron on either side, also called special form, just like we saw with bitstrings. As we learned, bitstrings could be any number of bits. Binaries are where the number of bits can be evenly divided by 8. When working with binaries, we will typically use the term bytes. 1 byte is 8 bits. A byte can represent integer numbers from 0 to 255. It is common to also see values in the hexadecimal format. Let's open up our terminal, command space, terminal, and let's make our new project. So mix new, and we'll call this one binaries, enter. Let's go ahead and cd into the binaries directory and kick off our Elixir shell with iex space dash capital S space mix. And I will go ahead and make this bigger for us. Forgot to do that. There we go. Okay, so like I said, a byte is 8 bits, and it can be anything from 0 to 255 in value. So 255 is also equal to a hex number of FF. And F equals 15, or in binary, it would be 4 on bits, so 4 ones in a row. So let me just do something here. So if we went like this, double chevron, 255, and then double chevron to close it off. If we said, is this equal to double chevron, and to write hex in Elixir, you have to do a 0 followed by a lowercase x, and then the hex value. So we can just do FF and then double chevron to close it off and then hit enter. So 255 is equal to the hex value FF. Just to explain a little bit, let me just write this on the screen. So 1F is equal to 4 binary bits. And so that is 15 because we have value 1, 2, 4, and 8. You add those all up, they equal 15. When you combine two hexadecimal F values, it's 8 bits completely, and that equals 255 because we take 4 from the first F and then 4 from the second F, and that is all the bits are on, and that value is 255, which is why we saw that 255 is equal to hexadecimal FF. Okay, clear that out. And just to dive a little deeper, we can even pattern match across multiple bytes. We can compare across multiple bytes. So we can even do something like this. Double chevron, we can do value 2, comma, 4, comma, 6, comma, 8, and then double chevron. And then we can say, is this equal to, and then we can do the hexadecimal form of all these. So we can do 0x02, comma, and then we can do 0x04, comma, and then 0x06, comma, and then 0x08, comma, and this will be true as well. So whether it's an integer or a hex value, it's all the same under the hood. One little value that might throw you off a little bit is if we do double chevron 0x10 and then double chevron to close it off, you might think this would be like equivalent to 2 or something like that, but it is equal to 16. So why is this? And if you remember just the way I demonstrated FF in a row, we basically have a 1 and a 0. That's our hexadecimal value, right? So that 0 actually represents four zeros, and that 1 represents a 1 right there, but it also represents 4 bits, so we have 3 more in front of it. And if we went and figured out what value that is, it would be 1, 2, 4, 8, 16. So there you go. That is why hexadecimal 10 equals 16. So a null byte is also the same as just writing a 0. So if we just did this, it will come back as 0, but that is also a null byte, okay? All right, so I'm gonna clear the screen. You can also have overflowing bits. And what that means is, what if we have a value over 255? So anything that overflows, they get truncated. So integer values greater than 255 will overflow, and only the last 8 bits of the integer will be used. So if we did something like double chevron 256, 256 double chevron, and I hit enter right now, we're gonna get a 0 back. All right, so what's happening here? I'm gonna draw again. So essentially 255 is 8 bits on, right? So 4, 5, 6, 7, 8. That is a full byte, and we're passing in 256. So they're trying to cram an extra bit in there, and that doesn't work. So what's happening is this is getting pushed out into another byte, and the first value of a byte starts at 0. So that gets kicked out, and we're going to have just an empty byte here. So 8, 1, 2, 3, 4, 5, 6, 7, 8. So the far left bit is called the most significant bit. It gets truncated and it creates a new byte starting at 0, okay? And then just for you guys to know, the very first bit is the least significant bit. So you have the least and the most. But since we had an extra bit in this byte, it gets pushed into its own empty byte starting at 0. So that is why 256 equals 0. And now if we did 257, it's going to equal, whoops, I missed a chevron. Oh, and then it's gonna do this on me. All right, 1 second. Okay, so if I do double chevron 257, we're gonna get a 1 value back. It pushed the last 2 bits out into its own byte. And so 0 gets the first bit, and then the next bit increases the value to 1. So we would have 1, 2, 3, 4, 5, 6, 7, 8. And that is why 257 got pushed to that value. Let's clear that out. So pattern matching is also extended into binaries. We can pattern match and grab just a portion of binary data, which is pretty helpful. We can do things like this. Double chevron. Remember when we were setting variables with bitstrings? We can do the same thing here. So we can set a variable head, double colon, and then binary dash size, opening parentheses, and we can just say we want to grab the first 4 bytes. And then closing parentheses, comma, and then we can set the rest of the binary to a body, double colon, and the type here is binary. And then just close out with the double chevron, and we can set this equal, just 1 equal sign. We can set this equal to double chevron, and we can just go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8 separate bytes here, right? I'm just using numbers 1 through 8 just because they're the easiest to type on my keyboard. So when I hit enter here, we just set this series of binaries to head and body. So now if I typed in head, we're going to get 1 through 4. And then if we type in body, we're going to get 5 through 8. So that's pretty cool. We're able to grab just a portion of the binary and use pattern matching to set it. So let's open up our project now. All right, so let's expand the lib directory and double click on binaries. And let's just go ahead and delete this hello world function because we don't need it. Okay, so first I want to show you how we can use binaries using guards. So a very common way to check file types is by their binary signature. The first few bytes of files are normally unique, and that file type allows us to verify its type or identify the file type, which is really cool. So one thing I want to do here is I'm going to just drag a PNG file. You guys can grab any PNG that you need. And I'm going to grab this one. And if you need this, you can get it from my GitHub. So I just grabbed my logo, the backend stuff logo, and dragged it into the lib directory. And then let's go back to our binary. And we're going to just make a nice little helper function to grab the binary data of this file. So I'm just going to say def get PNG binary, opening, closing parentheses, and then do and end to close off the function. Elixir has a nice built-in module called file.read. And this returns the contents of a file in binary, which is really cool. And then we can also use another built-in function, path.join, which takes two strings and joins them together like a path. So we can just go double quotations, lib, and then close those, comma, close the quotations, comma, opening quotations, and then we just type in bs_logo.png, closing quotations. And that will basically just create a string path for us, lib / the name of our file. So if your file is named something different, if you're not using the bs_logo, just put the name of your PNG with the extension right there. And then let's save it and go back to our terminal, recompile. And now if we go to binaries.getPNG, binary, hit enter, you see it returns binaries. Okay, that is pretty cool. So now how do we know how to check that this is actually a PNG file? Let's first go to, we want to pull up a Wikipedia URL. Let me just drag it over here so we can see it. All right, so there's this nice Wikipedia, and I'll have this URL in the description of this episode. And it gives us all the hex signatures of different extensions. So I'm just going to do a Command F and search for PNG here. And here we go. We found it. And this is the signature of a PNG file. So this hex 89504E. I'm just going to copy it real quick. And let's go back to our VS Code. And let's make a function under our get PNG binary. And I'm just going to paste these values so we can remember them and just comment them out. All right. So now that we have the signature of our PNG file, we can write a function that will grab the first, let's see, 1, 2, 3, 4, 5, 6, 7. So it'll grab the first 8 bytes out of our file binary. And then we want to compare it to the PNG signature to confirm or deny that it is a PNG file. So if we just made a function called def type underscore from binary, opening parentheses, and then our argument will be file underscore binary, and then closing parentheses, and we're going to use a guard now. So we're going to say when. All right, now we want to know when this binary equals that file signature, okay? So there's a nice little built-in kernel function called binary part, and it takes 3 arguments. The first argument is the binary, so our file underscore binary. The second argument is where do we want to start it from? So in this case, we're starting at 0. We want to start at the beginning of this binary. And then the third argument is how many bytes do we want? And we want the first 3 bytes. So we would grab 3 bytes from, say, like location 50 if we wanted to, if we had 0 set as 50. But we want the first 3 bytes. I'm sorry, we want the first 8 bytes. We have 8 bytes. So we're grabbing the first 8 bytes starting at 0 from our binary string. All right, and when that equals, we want to just do our double chevron, or yeah, our double chevron. And now we want to just take the hexadecimal 89. So remember, we have to do 0 lowercase x 89 comma 0 lowercase x 50 comma 0x 4e comma capital E, and then 0x 47 comma 0x 0d 0 capital D comma, and then 0x 0 capital A comma, and then 0x 1 capital A comma, and 0x 0 capital A. Okay, so if the first 8 bytes equal this bit string of bytes, or this just binary string of bytes, comma, we want to just return a tuple of an atom OK, and then we're going to return a string that is image /PNG. So that is our media type now, right? Here, let me just, I don't want it to be cut off. So I'm just going to collapse that. Okay, so now you can see our function all in one line, and we're returning image /PNG if our file is actually a PNG. Let's go ahead and go back to our terminal. Let's recompile, and let's first use our little helper function that returns the binary for us. So we're going to say PNG equals, and then binaries.get PNG binary. So we're setting a variable called PNG. There we go. And now if we do binaries.type from binary, opening parentheses, and we pass in our PNG variable, closing parentheses, we should get a string returned with image PNG. And then there we go. We got our tuple. I'm sorry, not a string. So we got our tuple with an OK and our string image PNG. That's really cool, right? All right, let's go back to our project here. I'm going to open up this directory again. And this time I'm going to drag in a JPEG just right into our lib folder. That's my head. Let's go back to our binaries.ex, and let's just create a function just like we did above, but grab our PNG. So def get underscore JPEG underscore binary, opening, closing parentheses, do and end, and then just do a file read, and then we want to do a path.join, and then we're doing opening quotations, double quotes, lib, closing double quotes, comma, open double quotes, and this is called my underscore head.jpg, and then double quotes, and then 2 closing parentheses. All right, so now, excuse me. So now we have a function that will return a binary for a JPEG. So obviously it's not going to, I'm going to just collapse that again. Obviously it's not going to match this file signature, right? So let's just make a default fall through. So type from binary. We don't need a variable name because we're not using it. So just do an underscore and then close parentheses, comma, space do, colon, and then we're just going to return a tuple, but an atom air, comma, and then a string called unknown. All right, and then finish off that tuple with a curly brace. Let's hit save and go back to our terminal. Let's recompile, and then let's make a variable for our JPEG binary. So JPG equals binary.get JPEG binary, enter. And there we go. We have our JPEG binary data now. And now let's just test our function. So binaries.type from binary, opening parentheses, and let's pass in our JPEG variable. So JPG, closing parentheses. Now when I hit enter, we hopefully don't see image/PNG. We want an error, right? And there we go. So our JPEG signature does not match our PNG signature, and we returned unknown. It's pretty sweet, I think. All right, so now let's write a verification function that will grab the signature and check it for a JPEG. So let's go back to that Wikipedia link, and the link is in the description below. So now let's just go ahead and search for JPEG. And now this is going to be a little different. Like, look at all these different file types we have for a JPEG extension. Now, one thing I want to point out is, yes, they're all different, but the first 3 bits in all of them are the same. So I'm going to just copy and paste the first 3 bytes. I'm sorry, not bits. I'm going to grab those first 3 bytes. Let's go back to VS Code, and I'm just going to paste those here and comment them out so we can remember them. So now if we do def type from binary, and then we want to pass in an argument called file binary, close those parentheses off. And now when we need the first 3 bytes this time instead of 8. So we're just going to do binary part, pass in our file underscore binary from byte 0, and we just want the first 3 bytes. So close those parentheses off. And now when these are equal to, just 2 equal signs, double chevron, and now we do 0x ff comma 0x it is d8 comma 0x ff. So that is the signature of the first 3 bytes, and then we want to do a comma do, and then we're going to return a tuple, okay, and then quotations, so image/jpg. Close those parentheses off, close that last curly bracket, and save it. And now we're getting yelled at because you want these in order. We don't want it to hit our error before it checks for a JPEG. So just copy and paste or cut the error guard, and let's put it underneath our JPEG test, and now save it. And now let's pull up our terminal, and we can recompile. And now if we do binaries.type from binary and send our JPEG in, boom, we get our image/JPEG. Okay, so we can also use pattern matching, kind of like the same way we did in the Elixir shell where we set the head and the body, right? We can use this in the function signatures to match when selecting from multiple functions. So instead of using guards, we can use function signatures. So let's go back to our VS Code, and we can just like super easily do def type from binary underscore PM. I'm naming it a different function name because it is not part of our guard clauses, okay? And we want to open parentheses. All we want to do here is the double chevron. I'm just going to copy and paste the signature right here from our PNG check with the double chevrons, and I'm putting it down here as an argument, okay? And then inside the closing double chevrons, we're going to do a comma. And then we're going to do an underscore body because we don't care about the rest of the binary. We're just matching the signature. But we do need to do double colon here and set it as a bit string. Bit string. Okay. All right. And now if we just get on the other side, close off that parentheses, do a comma, do colon, and we just can return our OK tuple with our image forward slash PNG string, and then close off that curly brace. All right, so what is happening here with this argument? This is pattern matching. We're passing in a binary. If the binary matches up to this point, it's going to say, okay, return this tuple, right? And we don't care about the rest, so we're just setting that as a variable with an underscore in front of it because we're not accessing it. It doesn't matter to us. So now if we save this and go back to our terminal, recompile, and if we do binaries.type from binary underscore PM, what did I name it? Let's go double check. Type from binary underscore, okay, maybe I didn't save it. Okay, let's go back to our terminal, recompile. Oh, it did recompile. Okay, so binaries.type from, I must have typed from wrong. It's acting, oh, form. Okay, from, just one M. Save that again. All right, typos happen. Recompile. All right, so now if we do binaries.type from binary underscore PM and pass in our PNG variable, which is just our binary data from the PNG file, hit enter, boom. So we get our image forward slash PNG. Now let's go ahead and cover everything, the unknowns, the same way. So we can just do def type from binary underscore PM, and then we don't have a variable that we care about. So if nothing matches, it will get to this case, right? And then we can do comma, do colon, and then our tuple, so curly brace, say colon air, so our atom air, comma, and then just quotation, double quotation, unknown string will be returned, and then double quotations, close off that curly brace, hit save. And now let's go back to our terminal, recompile, and now let's just try our binaries.type from binary underscore PM, pass in our JPEG, close those parentheses, and we should get an error, right? The unknown. Boom. All right, so I just showed you how to use guards and pattern matching for checking the signatures of binary data for file types. Super powerful. You can do this. It's very useful. So if people are ever uploading JPEGs and PNGs, like profile pictures or anything to the apps that you're writing, you got to check file types. And the easiest way to do it is the binary data. All right, so it's challenge time. As always, I want you to write documentation for all our functions. I want you to write tests for all our functions. And I also now want you to verify a few more return types, or file types. I want you to do bitmap, which is BMP, and I want you to use GIF, GIF as well, and just use that Wikipedia link to find the signatures. That link is in the description below. And the hint, so BMP is for bitmap, GIF is GIF, GIF. It's GIF, guys. Just follow the pattern from the other image types. So you're going to do image / BMP, image / GIF, and that will be the type that you return. So add these for the guard technique and the pattern matching technique. And yeah. All right. So as always, if you need help or just want to check out the solutions, check out that GitHub link in the description. And if you have more questions or just want to hang out and chat, join my Discord server, Backend Stuff. That link is also in the description. If you want to learn how to build scalable, production-ready APIs, hit that subscribe button now. See you next time.